Hi, I'm Eveliina and I work in Biocode as an impact assessment specialist. And today I'll be talking to you about the agricultural carbon footprint in the food chain, and we'll cover some challenges and solutions related to the agricultural emissions and how to calculate them. So, as an introduction, as we all know, food is a necessity for humanity, and most of the emissions in food chain arise from agricultural activities. But then, on the other hand, even though the emissions in the agricultural sector are the largest, there is also the greatest potential for climate impact reductions. And then, when talking about the calculation of the calculation itself of the emissions, um, it requires a lot of resources, and therefore we will discuss how digital solutions could help sustainability experts to focus their resources in a more efficient way. So first we could take a look at the food journey from field to shelf. And here I have gathered the greenhouse gas emissions shares from industrialized countries. And as we can see, agriculture takes up to 55 or even more percent of the food chain emissions. And these emissions arise from land use and land use change activities, then fertilizer usage, then enteric fermentation of livestock animals, and then energy usage. Then 10% shares come from transportation and processing of the goods, and 5% from packaging. And now that we have the food product ready to be delivered to consumers, the retail and usage phase covers approximately 15% of the emissions. And these emissions arise from, for example, leakages of fluoride gases, which are used as refrigerants or in air conditioning systems. And it's good to note that the global warming potential impact of fluoride gases is much more greater than that of carbon dioxide, and therefore they are a significant emission source. Then energy usage for example, cooking and freezing the food in freezers or preparing it in a way that demands energy or electricity. Then 10% comes from the disposal, and these emissions arise mainly from the landfill emissions and then from the waste management practices. And here it is good to note that almost 1/3 of all produced human food is lost or wasted annually. And this means that we release 5.4 gigatons of carbon dioxide equivalents into the atmosphere every year, unnecessarily. And as a remark, with this amount of emissions, every person in the world could take sauna 140 times a year. So these emissions are significant. And even though we are now focusing in this presentation on the production side emissions, we should also acknowledge that the consumption patterns of people are very unsustainable, and those should be also taken into account when talking about the reduction of emissions in the food chain. So now we could take a look at the agricultural emissions and their sources. So here I have gathered 3 categories, with the first one being the soil organic carbon emissions. So these emissions arise from, for example, from converting forest land to croplands, and then from different kind of tillage practices. And here it is also important to consider that whether the cultivation happens on mineral or organic soil. Because when cultivating in organic soil, the carbon stored in the organic layers of the soil will be released into the atmosphere due to different tillage practices. And therefore, we should always promote the cultivation to be happening in mineral soils, because the organic and mineral soil carbon stocks behave a bit differently, and therefore the emissions from organic lands are much greater. And this difference between organic and mineral soils is very well illustrated by the fact that peat fields, which are organic soils, they produce approximately half of the agricultural emissions in Finland, even though they cover only approximately 10% of the agricultural land here. Then next I have here nitrous oxides and methane emissions. So these are divided into direct and indirect emissions. And the direct sources include those where nitrogen oxides are directly released into the atmosphere. And then the indirect emissions are caused by when the nitrogen is transported from agricultural systems to ground or surface waters through different kind of like drainage systems or surface runoff. And then lastly, here is the methane, and those emissions arise from the enteric fermentation and manure management of livestock animals. Then the third category is the emissions from production inputs. So, for example, the fuel consumption for machinery, and then crop processing, which demands a lot of energy, and so the emissions related to the electricity production, for example. Then the liming and pesticides. So all of these together make approximately half of the carbon footprint of a food product. And here is a more thorough breakdown of the agricultural emissions in Finland in 2021. So 54% of the emissions comes from the land use and land use change, and then 41% from the agricultural activities themselves. So these include the agricultural nitrogen emissions, enteric fermentation, manure management, and liming. And then only a few percent comes from the fuel usage. So why is it then important to understand the carbon footprint of food production? Well, because besides of forming over half of a product's carbon footprint, agriculture significantly influences also the overall emissions of food companies, so the scope 1 to 3 emissions. And this is because over 60% of food companies' emissions stem from raw materials, and they are usually produced on farm level because, for example, if your company produces bread, they will purchase wheat flour or wheat that is produced on the farm level. However, sustainable farming practices can still reduce greenhouse gas emissions by up to 30%. And here it is very crucial that food brands engage with their primary producers so that they can actually have climate impact, and it helps them also to adhere to, for example, SBTi targets. And those targets are currently very relevant in the food industry because many major food retailers are beginning to demand this information from food brands for their scope 1 to 3 emission calculations, because they want to make sustainable procurements and ensure that their climate impact can be reduced in the future. But here are some examples of climate actions that could be promoted in farm level. So firstly, cultivating on mineral soils and adopting regenerative farming principles, because this can increase the soil organic carbon stocks. Then using organic and low emission fertilizers, for example, animal manure. Then thirdly, utilization of renewable energy. So for example, farmers could install their own solar panels to the farm or then produce biogas from animal manure and use that as a fuel for their activities. Then cultivation of nitrogen fixer plants, for example, legumes, because these plants are able to fix the nitrogen from the soil so that it would not be released to the atmosphere or to other groundwaters or surface waters. And then the last point here is reducing waste streams and maximizing production efficiency. So, however, I would say that all of these 4 points go hand in hand with the last one. Because, for example, the usage of organic fertilizers coupled with measures to increase the soil organic carbon storage will be beneficial not only for the cultivation conditions and for the climate impact reductions, but also they may enhance the crop productivity levels. So the key message here would be to go from accounting to action. So instead of wasting the valuable time of sustainability experts who would create some greenhouse gas calculation models and trying to adhere to different reporting requirements and standards and protocols, the emphasis should be on promoting actions that contribute to making agricultural activities more sustainable. And the calculations themselves could be then conducted with digital solutions. And we could now first take a look at the different reporting requirements and the scope 1 to 3 emissions, and then the digital solution that could help in solving these issues. So now companies have an increasing pressure to report their scope 1 to 3 emissions. So scope 1 emissions are those that arise directly from burning of fossil fuels in, for example, production facilities or in company vehicles. Then scope 2 emissions describe the climate impact related to the purchased energy. So electricity, steam, heating and cooling, which is used in, for example, production processes or heating up the offices, etc. And then scope 3 emissions are divided into upstream and downstream activities. And as you can see from this picture, the subcategories of scope 3, or there are many of them. So this is also the most resource-intensive phase of the whole calculation procedure. And here also we can see that the purchased goods and services are one category. And if we remember from the last slides, this subcategory is also the one that can take over half of the company's whole emissions. And then let's take a look at the reporting requirements. So there are many protocols and standards that are giving guidance on how to report the scope 1 to 3 emissions or how to conduct the life cycle assessments of food products. But when it comes to scope 1 to 3 emission accounting, the GHG protocol is it's the internationally accepted framework for doing these calculations. And firstly, the emissions should be calculated for 7 different greenhouse gases. So carbon dioxide, methane, nitrous oxides, and then fluoride gases. And these results should be presented in metric tons and tons of CO2 equivalents. Then the fossil and biogenic emissions should be reported separately. So fossil emissions arise from, for example, burning of coal, oil, natural gas, and diesel, and then also from manure management. Then biogenic emissions arise from burning of biomass and biogas or other biogenic or fuels made from biogenic materials. And then all these results should be allocated by scopes 1, 2, and 3. And then I would like to give a quick overview of the different standards and protocols that are used for making these calculations. So firstly, the GHG protocol corporate and product standard provides guidance on how to make the scope 1 to 3 calculations for company emission accounting and for the product carbon footprint. Then the ISO standards, then IPCC guidelines for national greenhouse gas inventories, and then the product environmental footprint guidance. And there are also other ones, but these are some of the most significant and internationally or EU-wide recognized standards and protocols. And some of them provide thorough information on how to actually conduct the calculations by providing, for example, equations. But then some of them, for example, the GHG protocol and ISO standards are more giving an overview or general guidelines on how to conduct the calculations. And actually now I would like to show you the Biocode calculator and to give an overview how this kind of digital solution could help, for example, your company to calculate the carbon footprint emissions. So here in the Biocode calculator, the first step would be the calculation of the crop carbon footprint. So all of your primary producers can calculate their footprint of their produced crop with this calculator. So I can give you an example. So here, they will just input all the necessary values or variables that are being asked here. So for example, information about the fuel usage and what kind of land management or soil management practices they are using and have they changed during the past 20 years. And then you can calculate the carbon footprint for your crop. And here in our case, it was now 3.32. And then when we move on to the Biocode for products, this value, this plant-specific value here, can be utilized as a raw material emission factor in the product side. So if we want to calculate the carbon footprint of wheat bread, which uses directly the wheat grains from your suppliers, it can be inputted here, and this value could be changed according to the one that had been calculated in the producer tool. And then finally, we can move on to the company emission calculations. So here your company is able to calculate all of the supply chain emissions arising from scope 1, 2, and 3. But next, I would still like to present some typical solutions which might arise when calculating the carbon footprint of food products, or actually any products, because there's are kind of similar kind of issues when it comes to LCA or like life cycle assessments or scope 1 to 3 calculations. So firstly, the data collection. It might be a very intensive, like resource intensive phase, and also the data quality will define the quality of the results. So you should have to use whether to use primary versus secondary data, but also the standards and protocols, they give you guidance on how to make these decisions. And also one point is that engaging suppliers and producers well in advance is very important, but it might also be challenging. And then emission factors. There are a lot of different databases or sources for the emission factors. We have academic literature values, modeled emission factors, or you can model them yourself, and then different databases. And they are also provided in different frameworks. So for example, in life cycle assessment framework, or then when it comes to scopes, then in market-based or location-based factors. So you always have to kind of know what kind of data you are looking for and then make the decision according to that. And then available resources. So it is very important to ensure enough human and financial resources for the calculations. And companies can whether choose between external or in-house calculation, or then use a combination of both. And then the level of uncertainty. So data quality and accuracy of emission factors, they will always bring some level of uncertainty, but also the standards and protocols and guidances, they give you like, they advise you on how to actually measure the uncertainty level, like the data quality and the overall quality of the results. But with this all being said, I would like to also say that when using the digital solutions, for example, Biocode calculator, which I just presented, you don't have to worry about the different kind of protocols and what kind of emission factors should I use, or all of these things that might bring a bit of like challenges to the calculations, because they are all incorporated into the Biocode. But yeah, with this being said, I would like to thank you all, and hopefully you get some important or interesting information from this presentation. Thank you.